So on the next page of 7.1, we will just be looking at two different questions. They're asked, phrased differently, but you'll notice that the process is essentially identical between them. So the setup information, we're dealing with heights of males that are known to be normally distributed. The average height is 60 inches, standard deviation of 5. So these are rather short males wherever they're at. So I'll identify mean of 60, standard deviation of 5. So now for question A, what percentage of men are between 52 and 63 inches tall? So since we have our normal distribution, we will draw our first normal curve, which I'll label X for data world. And so we know it's centered at 60, right? The mean is 60. 52 to 63, 52 is definitely to the left of 60. 63 is somewhat to the right of 60. So I will just label 52 to 63, and I'll shade in that area to represent what we're looking for. Now, with that picture, I want to convert it over into z-score world. So a couple of z-scores, data value minus mean over standard deviation for the 52. So that'll be negative 1.6. And then the other one, I'll just put it right below for 63. 63 minus 60 divided by 5. And that'll be 0.6. So we have two z-scores here, negative 1.6 representing 52 and 0.6 representing 63. So I'll put in my negative 1.6 z-score there, my positive 0.6 z-score there, and still shade between them. So now we've converted our picture. We can then take our picture in z-scores and go to our calculator function of normal CDF of negative 1.6 to 6. And the normal CDF of negative 1.6, sorry, to 0.6, I think I said 6. From negative 1.6 to 0.6 is 0.6709. If we round that to 4 places. Because again, remember, that is a probability coming out of the normal CDF. And so we could say, as a summary, as a sentence here, 67.09% of men are between 52 and 63 inches tall. That would be the interpretation of that number as a percentage, right? That's the key. Okay, so for B, same information. The question is just asked differently. What's the chance that if a male is randomly selected, his height will be at least 62? Now, it's a different question, but like we said earlier, the difference in percentage versus chance or probability, they're still the same question. They're still area under the curve. So we would still want to draw a bell-shaped curve. Now, when we're in data world here, again, the center is 60, so we're asking for at least 62. So 62 would be to its right, and at least would mean 62 or more. We then want to convert that bell-shaped curve from data world to z-score world. So we need one z-score. We just need the z-score of 62. So 62 is the data score, minus the mean, which we said was 60, over the standard deviation, which is 5. So that'll be a 0.4. That 0.4 is the z-score of that location, of that line there in our distribution. So again, same picture representing the same information, but now that we're in z-score world, we can use normal CDF, and we can start at 0.4, continue to the right forever, so something like a positive 10, and then we can see what we get for the normal CDF there. Coming out to be 0.3446 if I round. And so interpreting that number as they asked it, as they phrased it, the probability of a male being selected in that range. So we'll say something like the probability a randomly selected male has a height of at least 62 inches is 0.3446. Now you can always represent probability as a percentage. You could still write this as 34.46%. It's just the idea of the phrasing of the sentence based on the phrasing of the question. Also, I will mention this phrase that I've used here, and we see randomly selected. There's a reason why I'm going to keep using that phrase potentially in most of these these sentences, because eventually we'll be looking at a different situation, a different scenario, where we're not necessarily randomly selecting an individual, a single data value or object from the set of data.